My lovely students, welcome to Mathological. In this session, we'll be discussing the graphs of exponential function and logarithmic functions. Start करते हैं session. And if you've not already subscribed to the channel, then make sure to subscribe to the channel as well as press the bell icon. You can also join Telegram channel Mathological or can message me on Telegram at adityakt. So at first, we'll be discussing exponential functions. Graphs of exponential functions. Graph of y is equal to a to the power x. Now, since x is the variable, a will be some constant, so there will be two cases. First case will be when a is a value greater than 1. For example, if y is equal to 2 to the power x or 3 to the power x, or maybe e to the power x, where e is approximately 2.7. Any value of a that is greater than 1, or second scenario will be when value of a is less than 1. For example, 1 by 2 to the power x, 0.7 to the power x, etc. etc. कुछ भी वैल्यू हो सकता है less than 1. तो दोनों केसेस में ग्राफ will be different. So first of all, let us discuss the graph when the value of base is greater than 1. Okay. So if a is greater than 1, let us take one of the examples because graph in all such cases will be similar in shape. For example, let us say we have taken the example y is equal to 2 to the power x. A is equal to 2. So in such a case, if you put x equal to, let us say, 0, so 2 to the power 0 will be equal to 1. If we take x equal to 1, 2 to the power 1 will be equal to 2. If we take x equal to 2, 2 square will be equal to 4. X equal to 3, 2 cube will be equal to 8. So clearly the graph is going to rise very fast as we increase the value of x. For x equal to 4, 2 to the power 4 will be equal to 16 and so on. If we take negative values of x, for example, minus 1, so 2 to the power minus 1 will be equal to 0.5. For minus 2, 2 to the power minus 2 will be equal to 0.25. 1 by 2 square, which is 0.25. For x equal to minus 100, a large value, this will be 2 to the power minus 100 or 1 upon 2 to the power 100, which will be almost 0. 0 के बहुत पास चला जाएगा, बहुत large value होगा, 1 upon something that is very large. So this will be almost 0. But in all the cases, हम x को कितना भी decrease करें, even if x is minus 500, this will be 1 upon 2 to the power 500, so very close to 0, but still a positive value. Very close to 0, but still a positive value. So clearly 2 to the power x is always greater than 0. So y will always be greater than 0, never equal to 0. For x equal to 0, this is equal to y is equal to 1. For x less than 0, the value of y is less than 1, but always greater than 0. This will be somewhat like this. And then on the right hand side, this will be increasing very, very fast. Very, very fast. As the value of x is increasing, the y will be increasing very, very fast. The increase हमारा बहुत steep होगा. Isn't it so? So the rise is very steep. As the value of x is increasing, the rise is very steep rise. Okay. And for x equal to 0, the y is equal to 1. For x equal to 1, the y is equal to 2. And for x equal to 2, the y will be equal to 4 and so on. And in general, this will be the graph of y is equal to a to the power x for a greater than 1. क्या appreciate कर पा रहे हो, समझ पा रहे हो? Is that clear? Okay. Similarly, this will also be the graph for y is equal to e to the power x. For y is equal to e to the power x also, this will be the graph. Okay. Now let us take very large values of x. For example, 2 to the power 10. That is 1024. 2 to the power 20. That will be 1024 whole squared, or which will be almost 1 million plus. So as the value of x is increasing, the rise of y will be very, very steep. क्या ये appreciate कर पा रहे हो? Clear है बात? Next example लेते हैं when a is less than 1. Second scenario, when the base is less than 1. So what will be the graph? Y is equal to a to the power x. Let us say y is equal to 1 by 2 to the power x. Now if we take x equal to 0, 1 by 2 to the power 0 will be equal to 1 only. For x equal to 1, 1 by 2 to the power 1 will be equal to 0.5. For x equal to 2, this will be 0.25. So basically हमने 2 to the power x की जगह 1 by 2 to the power x लिया, तो the graph on the left hand side will be shifting to right hand side, and graph on the right hand side will be shifting to left hand side. Because for x equal to -1, this will be 1 by 2 to the power -1, which will be equal to 2 to the power 1, and hence 2. For x equal to -2, this will be 1 by 2 to the power -2, which will be equal to 4, and so on. So the graph of right hand side earlier will be shifting to left hand side, or left hand side वाला right hand side में switch हो जाएगा. So this will be the kind of graph for y is equal to a to the power x when a is less than 1. Okay. So now you can compare both the graphs. So in this case, when x value is negative, so the rise of y will be very steep after a while. Isn't it so? Clear? Now let's take next graph, the graph for y is equal to log of x on the base a, logarithmic function. Graph for a logarithmic function. Even in this case, we will be having two cases. First case when the base is greater than 1, and the second case when the base is less than 1. So first of all, let us take first case when base value a is greater than 1. And let us take one example, that y is equal to log of x on the base 10. Y is equal to log of x on the base 10. ये पहला एग्जांपल लेते हैं अपन, ठीक है. So obviously whenever we are taking log, so the value for which we are taking log, that value should always be a positive value, यानी कि x should always be greater than 0. So log will not be defined for any value of x that is non-positive, that is 0 or negative. So x should always be greater than 0. So if we take x equal to 1, log of 1 will be equal to 0. Okay, if we take x equal to 1, log of 1 will be equal to 0. If we take x equal to 10, so log of 10 on the base 10, that will be equal to 1. For x equal to 100, there is a steep increase from 1 to 10, 10 to 100. For log of 100 on the base 10, that will be equal to 2. 1000, log of 1000 on the base 10, since 1000 is 10 cube, so this will be 3. If we take x equal to 1 by 10, log of 1 by 10 on the base 10 will be -1. 1 by 100, -2. 1 by 1000, -3, and so on. So the graph of logarithmic function when base is greater than 1, so at x equal to 0, sorry, at x equal to 1, the graph will be, the y value will be 0. This will be somewhat like this. But as the value of x is increasing, rise in value of y is very slow. From 1 to 10, there is a rise of only 1 unit in y. From 10 to 100, only rise of 1 unit. From 100 to 1000, only rise of 1 unit. Next value, our 10,000 log. For 10,000, log of 10,000 will be equal to 4. So the rise in y value for the same rise in x is very slow. So log graph is increasing very slowly. Log increases very slowly. Exponential function was increasing very fast as the value of x was increasing, but quite the opposite, logarithm function increases very slowly as the value of x is increasing. So for the same increase in value of x, the increase in y is definitely very slow as the value of x is increasing. क्या ये क्लियर है? क्या ये पैटर्न समझ पा रहे हो? ओके, क्लियर है. नाउ नेक्स्ट केस लेते हैं व्हेन बेस वैल्यू इज लेस देन 1, a is less than 1. For example, log of x on the base 0.5. So if we take x equal to 1, log of 1 on any base, that is 0. If we take x equal to 2, for x equal to 2, log of 2 on the base 0.5. Log of 2 on the base 0.5. 2 is basically 0.5 क्या 1/2 है, तो 1/2 पावर -1 है, तो दिस विल बी -1. Log of 4 on the base 0.5, so -2, because 1/2 to the power -2 is equal to 4. 8, log of 8 on the base 0.5 will be -3, and so on. If we take x equal to 1/2, which is 0.5 only, so log of 1/2 on the base 1/2 will be equal to 1. For 1/4, this will be 2, and so on. In this case, shape कैसा होगा ग्राफ का? At x equal to 1, y will be equal to 0, and this will be the shape. Is that clear? So in contrast, if you compare these two graphs, the fourth quadrant graph shifts to the first quadrant, and first quadrant graph is shifting to the fourth quadrant when value of a is less than 1 in case of greater than 1. Isn't it so? Clear? Okay. Now let us compare both the graphs, logarithmic as well as exponential functions, because if we are taking y is equal to log of x on the base a, so by definition of log, this implies that we need to find out what is value of x in terms of power of a, or basically a to the power y. This means that a to the power y is equal to x. A to the power y is equal to x. So if our value of a is greater than 1, a to the power y equal to x का ग्राफ कैसा बनेगा? भाई at y is equal to 0, a to the power 0 will be equal to 1. At y equal to 0, right, this is x, this is y. At y equal to 0, this will be on x-axis, so this will be equal to 1. Isn't it so? And when the value of y is increasing, the value will be increasing fast. This graph will be somewhat like this. The graph of logarithmic function, or the graph of a to the power y is equal to x. This will be the graph. Isn't it so? क्या ये clear है? Because logarithmic function and exponential functions are inverse functions of each other. Isn't it so? Okay, and if we compare both the graphs, the two graphs, one graph is for y is equal to log of x on the base a, and y is equal to a to the power x, and both when a is greater than 1. So the first graph for y is equal to a to the power x, this graph will be like this. In the second graph, y is equal to log of x on the base a, this will be like this. Both the graphs are reflecting each other, mirror images across the line y is equal to x. This is line y is equal to x, and this is the graph of log of x on the base a, and this is the graph of a to the power x, which both the graphs are mirror images of each other because these functions are inverse functions. A logarithmic function and exponential functions are inverse functions of each other. That is why the graphs are shaped like this. Isn't it so? ठीक है, mirror images about the line y is equal to x. About y is equal to x. Okay, clear है? Now let us take one question. एक क्वेश्चन लेते हैं. The question is, find the number of solutions of 2 to the power x is equal to x to the power 6. Number of solutions of 2 to the power x is equal to x to the power 6. कितने solutions मिलेंगे? Now in such a case, x to the power 6 तो ठीक है, algebraic function है, but 2 to the power x का हम ग्राफ ही बना सकते हैं, otherwise this equation cannot be solved. So for any such equation, यहाँ पे कि one side is, left hand side is exponential function, right hand side is a polynomial function. One second. So we cannot solve this algebraically. ठीक है, इसके लिए हमें ग्राफ ही फॉर्म करना पड़ेगा, और ग्राफ फॉर्म करके पैटर्न आइडेंटिफाई करके ही इसको सॉल्व कर सकते हैं. For x to the power 6, we know the graph. The graph will be somewhat like this. राइट हैंड साइड थोड़ा सिमेट्रिकल बनाना चाहिए था, एक बार फिर से बना लेते हैं. दिस विल बी काइंड ऑफ द ग्राफ फॉर ठीक है, चलो अभी इसको ही रखते हैं. दिस इज द ग्राफ फॉर x टू द पावर 6. ओके, एंड टू द पावर x का ग्राफ कैसा बनेगा? यू नो एट x इक्वल टू 0, एट x इक्वल टू 0, टू द पावर x will be equal to 1, and on the left hand side the graph will be shaped somewhat like this. Clearly there will be an intersection point on the left hand side. Right hand side में श्योरिटी नहीं है कि ग्राफ का शेप कैसा होगा. शेप का एक आइडिया तो है, बट इट माइट बी अ ग्राफ that is not touching x to the power 6 and rising, isn't it so? Or this is the, let us say, first scenario. Or the second case may be that the graph is intersecting with x to the power 6 and going like that. This might be the second case. Whether it is the first case or the second case, that we are not sure. That we have to identify. Because if it is the first case and it is rising steeply and not intersecting with x to the power 6, then we'll not be having any intersection point apart from the one intersection point when x is negative. But in the second scenario, we'll also be having another intersection point or maybe more intersection points depending upon the condition. Isn't it so? So pause the video, think about this question, whether the graph will be like the first type on the right hand side of x-axis or the second type. Pause the video and take your time. ठीक है, वैल्यूज, कुछ वैल्यूज पुट करो, some values you will be putting and then you will be getting idea, okay, for both these graphs, to the power x and x to the power 6. So if the graph is intersecting, so in such a case क्या होगा? If there is an intersection point, so before that intersection point, the graph of 2 to the power x will be above that of x to the power 6, and after that intersection point, graph of 2 to the power x will be below that of x to the power 6. Isn't it so? यानी कि बीच में कहीं पे इक्वल होगा, उससे पहले दोनों ग्राफ्स में से एक ग्राफ अबव होगा, दूसरा बिलो होगा, और फिर वो सिनेरियो चेंज हो जाएगा आफ्टर द इंटरसेक्शन पॉइंट. Isn't it so? तभी तो ये पॉसिबल है. एंड इफ that is not happening, if graph of 2 to the power x is always greater than x to the power 6, then in such a case there will not be any intersection point whatsoever. So if we take x equal to 0, we know for x equal to 0, 2 to the power 0 is 1, or 0 to the power 6 is 0 only. At x equal to 1, 1 to the power 6 is 1 only, and 2 to the power 1 is 2. So clearly 2 to the power x is above that of x to the power 6. At x equal to 2, 2 to the power 6 is 64, and 2 square is equal to 4. So in the first case, यानी कि for x equal to 1, 2 to the power x का ग्राफ क्या है? x to the power 6 के above है, because 2 is greater than 1. But in the second case, 4 is less than 64. 4 is less than 64. So we can clearly say that the case will be, the second wala case will be there, because let us say for x equal to 1, the value of x to the power 6, this is equal to 1. But 2 to the power 1, this is equal to 2. But then for x equal to 2, 2 to the power 2, this is equal to 4. But this is 64. ठीक है, ग्राफ एग्जैक्टली शेप में नहीं बना है, बट समझ पा रहे हो कि और भी जरा हमारा कर्व स्टीप होगा. तो x to the power 6 is equal to 64 at x equal to 2. So clearly they must be cutting between 1 and 2 at some point. There must be another intersection point between 1 and 2. So let us say this is our first intersection point. Let us say that is x1. This will be our second intersection point, that is, let us say, x2. So we are now sure that x1 and x2, there are two intersection points for sure. But are we definitely sure that there are only two intersection points and not more? Are we definitely sure? देखो, जब भी कभी ऐसा केस हो कि we have one function that is an exponential function and the second function that is a polynomial function. The exponential function after a while increases very fast. If the base is greater than 1, तो after a while this will be increasing very very fast. यही हमने डिस्कस किया था, ये हमने अभी पैटर्न ऑब्जर्व किया. So definitely there will be another intersection point. After a while, what will happen? That this graph will be very steep, and will be increasing very very fast with the slight increase in the value of x. And x to the power 6 will somewhere intersect at a larger value. So there will be another intersection point that will be, let us say, x3. And after that, definitely 2 to the power x will be increasing very very steep. So there will not be any further intersection point. There will be total 3 intersection points in such a case. क्या ये क्लियर है? अभी हम पैटर्न वैल्यूज देख के भी इसको ऑब्जर्व करेंगे, बट क्या ये बात समझ पा रहे हो कि डेफिनेटली इफ यू हैव टू ग्राफ्स, वन ग्राफ इज a to the power x, अदर ग्राफ इज अ polynomial function, let us say x to the power 6 or maybe x to the power 6 plus x to the power 5 plus x to the power 4 and so on, तो दोनों ही केसेस में हमें पता है कि a to the power 6 x वाला ग्राफ will always supersede graph of x to the power n at a larger value of x, larger value of x, if a is greater than 1. Okay, let us take some large values. For example, if we take x equal to 5, so at x equal to 5, this will be 5 to the power 6 and this will be 2 to the power 5. Like still this is lower than this value. If we take x equal to 10, x to the power 6 है, let us say 30 ले लेते हैं. So at x equal to 30, this will be 30 to the power 6 and this will be 2 to the power 30. Now 2 to the power 13 can be written as 2 to the power 6 to the power 2 to the power 5 to the power 6, okay, which is equal to 32 to the power 6. So 32 to the power 6 is definitely greater than 30 to the power 6. So clearly हमारा after a while क्या हुआ कि at x equal to 30, graph of 2 to the power x is above that of x to the power 6, isn't it? So और भी बड़ी वैल्यू लेंगे, फॉर एग्जाम्पल अगर हम 60 ले लें तो at x equal to 60, x to the power 6 will be 60 to the power 6 only. This is a very huge value, but still very, very small in comparison to 2 to the power x, because 2 to the power x will be 2 to the power 60, which will be 2 to the power 10 to the power 6, and 1024 to the power 6, which will be much, much, much larger than 60 to the power 6. As the value of x is increasing, clearly 2 to the power x is increasing at a much, much faster pace than x to the power 6. क्या ये clear है? कि definitely there will be a third intersection point. So number of solutions in this case will be equal to 3. Our answer will be equal to 3. Is that clear? ठीक है. So as we discussed in the previous session, so if x is greater than 1 or x greater than 1, x to the power n will be greater than x to the power 4 if n is greater than 4, will be greater than x cube, will be greater than x square, will be greater than x, will be greater than square root of x, will be greater than cube root of x and so on. But additionally, ये तो सारी की सारी चीजें पैटर्न में होल्ड कर ही रही हैं. Additionally, n to the power x will also be greater than x to the power n for larger values of x. ठीक है, पैटर्न ऑब्जर्व करना है, बट फॉर लार्ज वैल्यू ऑफ x, बिकॉज n to the power x is an exponential function and x to the power of n is a polynomial function. At a very large value of x, n to the power x will definitely be greater than x to the power n. क्या ये पैटर्न अप्रिशिएट कर पा रहे हो? क्या ये बातें समझ पा रहे हो? इज दैट क्लियर? ठीक है. सो इफ यू अंडरस्टूड दिस कॉन्सेप्ट नाउ, तो मेक श्योर टू कमेंट अबाउट दैट यस यू अंडरस्टूड दिस प्रॉपर्ली. ओके, एक और क्वेश्चन कर लेते हैं इससे बेस्ड, और वहाँ पे भी मेक श्योर टू पॉज द वीडियो एंड ट्राई टू सॉल्व दैट क्वेश्चन योरसेल्फ फर्स्ट. तो let us say find a number of solutions of f of x is equal to 1 by 3 to the power x and g of x equal to x square plus 2x minus 3. So how many intersection points will be there if we have fx equal to 1 by 3 to the power x and gx is equal to x square plus 2x minus 3? Pause the video and try to solve this question yourself first. इन दिस केस हमारे पास क्या है, fx है 1 by 3 to the power x, तो ग्राफ हमारा क्या होगा, a to the power x का इस बार उलट जाएगा, रिवर्स हो जाएगा. लेफ्ट हैंड साइड विल बी ऑन द राइट हैंड साइड, और बेसिकली लेफ्ट हैंड साइड विल बी इंक्रीजिंग एट अ मच फास्टर पेस, isn't it so? Right hand side will be from 1 to 0, from 1 to 0. At x equal to 0, this will be equal to 1. 1 by 3 to the power x will be equal to 1, and as the value of x will be rising, 1 by 3 to the power x will be tending towards 0, isn't it so? ठीक है. और gx क्योंकि हमारा ये क्या है, क्वाड्रेटिक फंक्शन है, तो उसके लिए भी हमें आइडेंटिफाई करना पड़ेगा ग्राफ कैसा बनेगा, कहाँ पे मिनिमा लाई करेगा. एक्स स्क्वायर प्लस 2x माइनस 3, this can be written as x square plus 3x minus 3. So x into x plus 3 minus 1. So x minus 1 into x plus 3. This will be our graph of gx. So critical points are minus 3 and 1. And minimum value of gx will be at minus b by 2, which will be minus 2 by 2, यानी minus 1. gx minimum will be at x equal to minus 1. or between -3 and 1. So at x equal to -1, minimum value will be -1 square, which is 1, 1 minus 2 minus 3, so that will be -4. Okay. Minimum value will be at -1 and that will be -4. And at x equal to 0, value will be -3. This graph will be somewhat, this is the vertex, this will be the graph for gx. And graph of x on the left hand side will be rising steeply. तो लेफ्ट हैंड साइड पे तो हम अगेन श्योर नहीं होंगे कि whether the graph will be cutting the left hand side of the graph gx or not. उसके लिए आइडेंटिफाई करना पड़ेगा, but right hand side we can be sure that at x equal to 0, the graph will be 1 by 3 to the power 0 will be equal to 1, and then this will be decreasing consistently. So this will definitely be intersecting at one point on the right hand side. Left hand side में there can be two cases. Either it will not be intersecting at all, or it will be intersecting at one point, and since there will be a steep rise after a while, so this will be intersecting again at a second point. Either this scenario will be there, in which case we'll be having two intersection points on the left hand side, or there will be zero intersection points. So either the first case or the second case. So again we have to identify whether the first case is there or the second case is there. So for that we need to find out values. Okay, we'll have to find out the value of fx and gx for some values of x, fx and gx for negative values of x. Okay, so for x equal to 0, so we know that definitely gx is below that of fx. ठीक है, तो 0 पे तो चेक करने की जरूरत नहीं. x equal to -1 पे 1 by 3 to the power -1 will be equal to 3 only. fx will be equal to 3 only, and gx at -1 is equal to -4. अच्छा, till -3, when x is greater than -3, तो gx is less than 0. और हमारा fx तो हमेशा ही पॉजिटिव है, तो इफ fx इज पॉजिटिव तो इंटरसेक्शन पॉइंट तो पॉसिबल ही नहीं है. Isn't it so? तो एटलीस्ट till x greater than -3, we know for sure that gx is lying below that of fx. Isn't it so? So at x equal to -3, gx is 0 and fx is 1 by 3 to the power -3. At this value, at -3, 1 by 3 to the power -3, which will be nothing but 3 to the power 3, which is equal to 27. So gx will be way above, that is at 27. Isn't it so? fx will be at 27. 1 by 3 to the power -3, that is equal to 27. So it is way above. At x equal to -4, fx will be 1 by 3 to the power -4 or 3 to the power 4, which is equal to 81. जबकि gx हमारा क्या होगा at x equal to -4 पे, this will be -4 -1, यानी कि -5 into -1, that is equal to 5 only. So clearly this is much larger. Much larger. अगर हम और बड़ी वैल्यू लें, let us say we take x equal to -10. At x equal to -10, 1 by 3 to the power -10 will be 3 to the power 10, which will be 3 to the power 5 whole squared. 3 to the power 5 will be 243. So this will be 243 whole square. But gx हमारा क्या होगा? gx will be at -10 -11 into -7, यानी कि 77, which is very small. तो clearly fx is rising very fast. fx का rise बहुत fast है और बढ़ता ही जा रहा है, जबकि gx अभी भी कहीं भी close नहीं है. तो definitely in this case our graph will clearly be like the first case. This will be our graph. So it will not be intersecting at any place gx. तो fx and gx will not be intersecting at the left hand side of x. ठीक है, right hand side में सिर्फ एक intersection point होगा, so there will be only one solution. Number of solutions in this case will be only one, and no intersection point on the left hand side of y-axis. So clearly only one intersection point will be there in this case. क्या ये clear है? Is this part clear? Okay, ठीक है. So इतना ही रखते हैं सेशन में. आई बिलीव जो भी डिस्कस किया वो समझ में आएगा और सारे के सारे क्वेश्चंस क्लियर हुए होंगे. इफ देयर इज एनी डाउट व्हाटसोएवर, देन मेक श्योर टू कमेंट अबाउट दैट डाउट कि क्या बात तुम्हें समझ में नहीं आई, क्या सारी चीज़ें क्लियर होती हैं नहीं होती. एंड ऑल्सो गिव अ फीडबैक इन द कमेंट सेक्शन दैट हाउ यू लाइक दिस सेशन एंड वेदर द कॉन्सेप्ट्स ऑफ logarithmic functions and exponential functions were cleared after this or not. In the next session of graphs, we'll be discussing some other types of graphs, and we'll also be discussing some bits of transformation. For this session, that's all about it, and Keep learning. Take care.